Okay, so good evening all and welcome back to the fourth week of TA live sessions for AI knowledge representation and reasoning. So before we get started, can you all hear me and is my screen visible?
Yes, sir.
Okay, thanks for confirming. So today we'll be discussing some questions related to the week 4 content, which is dealing mostly with first order logic and so I think without any further delays, we can get started. Just announcement for next week. So there is a possibility that next week on Tuesdays I might not be available. So the live session for the next week might be rescheduled, but you will be notified of the rescheduling through the Swayam portal. Okay, so just keep track of what day is the next live session falling on. Okay. Um, Thanks for muting. Okay, so let's get started with the questions for today. So, like I said, we'll be dealing mostly with first order logic questions, and some of these will be recall based questions, and some of them will be conceptual questions. And the first one is something that is kind of a mixture of both recall and conceptual based question. So, this question tells us that first order logic is a language that talks about a domain or the universe of discourse, and we can refer to the elements in the domain using which of the following. Okay, so which of the following do you think would be applicable for us to use to refer to the elements in a particular domain?
Answer is B and C.
Okay, so we have vote for B and C. Does anyone else think differently? So maybe let me try to draw something, and that might be beneficial. So let's say that we have this box represents our domain, okay, or the universe of discourse, okay, and let's say we have some subset of this domain. This basically represents a predicate, okay, and this could refer to something. For example, let's say if domain is the set of um, all whole numbers, let's say this subset P represents the set of all integers that are less than um, or that fall between 0 to 10. Okay, so um, so P will be a subset. Okay, within P there can be different elements. Okay, for example 1, 2, and so on and so forth. So these are examples of constants. Okay, we can have a variable as well. So a variable can represent different elements in a particular subset, and we can also have functions, right? So we can also represent the elements of a particular subset using these functions. Having this knowledge now, let's go back to the question. And now, do you think any option other than B and C would be correct?
D. D is also correct.
D, that's right. So so like some of you mentioned in the chat box as well as on the call, the correct options would be B, C, and D. Uh, E would not be a correct language because predicate represents a subset, not a single element. And then A is the non relevant option given over here. So I would just request to mute if there's no question. Yeah, thanks. Yeah, so A is a non-relevant option, so we can just discard it. Amongst B, C, D, and E, B, C, D are the correct options, and E is incorrect because predicate refers to a subset of elements, not a specific single element. Okay, so this was straightforward. I hope there are no doubts. If there are, please let me know. In the meantime, let's go to question 2. Okay, so question 2 tells us that um, So here we have defined a predicate called rich man. That is the name of the predicate or the subset. Okay. And we have a first order logic language, L, represented by these three entities: predicate, function, and constants. And we have a sentence, rich man Suresh, okay, in the knowledge base. So when we assert this sentence, when we write this sentence, what do we mean by that? Okay, which of these options do you think would be appropriate for the meaning of this particular sentence, rich man Suresh?
Option D might be correct.
Option D. Okay, so we have a vote for option D. That is
Option C.
okay. We have another vote for option C. So let's look at what we want to know over here. So this sentence, okay. Here we have chosen to name this predicate as rich man. Okay, let's say I name this predicate as rich man, but this predicate is nothing but a subset within a domain, right? Let's say another person comes in and decides to name this same subset something else. Let's say he wants to name this subset as rich woman. Both rich man and rich woman in that case would represent the same set of elements that fall within that subset, but they have different names, right? So a logical machine or a first order logic language that doesn't care about the actual English language meaning of the word rich man or rich woman. Okay, so just because the name of the predicate is rich man doesn't mean that it always has to be that subset will contain those people who are rich and those who are men. Okay, so the correct option here would be option D, which means that rich man is some subset of the domain D. It may or may not correspond to a set of those people who are rich and men. Okay, so that's why only D is the correct option. Okay, I hope this was also clear. So let's move on to question 3 then. So question 3 asks us about atomic formulas in first order logic. Okay, so you might recall the definition of first order of atomic formula from the weekly videos, and based on that, which of these options do you think would be correct?
I think option B should be correct.
Okay, we have a vote for option B and another vote for options A and B on the chat box.
So option B.
Okay, another vote for option B. So I think all of you are correct. All of you have identified the answer correctly, and that is that an atomic formula is a well-formed formula. Okay, and it is the smallest unit that can have a truth value assigned to it. An atomic formula cannot have logical connectives, because if it has logical connectives, it means that it is no longer the smallest unit. Okay, it can be broken down further. By the same logic, it also cannot have a unary connective, right? So A and B are the correct options. Okay, and just to verify, let's go over the definitions given in the lecture slides. Okay, so to understand, we'll first have to we have to go through a sort of a recursive definition. Okay, but we'll start from the bottom up, not from the top down. Okay, so first let's look at the definition of a term. Okay, so you can read through this, but basically if t is a variable, then we can say it's a term. If t is a constant, we can say that it's a term. Okay, if t1, t2, tn are n terms and f is a function that takes n arguments, then that function with all the n terms applied to it as arguments is also a term. Okay, this is the definition of a term. Now let's look at an atomic formula. So true and false are by default atomic formulas. Okay, this represents false, this represents true. If t1 and t2 are two terms, then this expression T1 equals T2 within parenthesis. This is an atomic formula. And then if P is a predicate, again which takes n arguments, okay, then the predicate of those n terms is an atomic formula. Okay. Now that we know what an atomic formula is, let's look at what a general formula is. So if alpha is an atomic formula, then alpha is also a general formula. And then if alpha is a general formula, then negation of that is also a formula. Conjunction of alpha and beta are also formulas. Alpha and beta connected by a disjunctive connector or is also a atomic formula, and connected by an implication is also is also a general formula. Not an atomic formula, but a general formula. Okay, so this is the definition of term, atomic formula and formula that we saw. And based on the definition that we have seen till now, we also have a definition of a sentence. Okay, so when we have a formula in first order logic, and if that formula does not have any free variables, then we will call that a sentence. Okay, so a lot of definitions to process at the same time, but just keep these in mind, and these will help us answering the next few questions. But coming back to this question, I hope this was clear. Okay, we know what an atomic formula is, so A and B are correct. Now let's look at question 4, which asks us what is a formula in first order logic. Okay, a general formula or a variable in a general formula. A variable x in a first order logic formula alpha. Which of the following do you think would be correct?
Sir, actually we can't see your screen, sir. We can see that sentence slide, sentence of LPC.
Okay, thanks for pointing that out. Yeah. So I'll just read the question once more. So this question asks a variable x in a first order logic formula alpha, and then which of the following options are true for a variable x in a first order logic formula alpha.
Sir, I think option B, I guess it should be correct.
Okay, one vote for option B. But if we say option B is true, then can't we say option A is also true?
Which necessarily be. Yes.
Right. So by that argument, A and B as of now are our votes. What do you think about option C and D?
Answer is A and B.
Okay, we have another vote for A and B also in the chat box. So that's great. I think all of you have correctly got it. A and B are the correct options over here. So a variable can be in the scope of it has to be in the scope of a quantifier, right? For it to be a sentence, right? Because a sentence by definition does not contain any free variable, so it has to be within the scope of a quantifier, and it can occur in the scope of more than one quantifiers also, right? So option A and B are correct. Option C is not correct because a variable by definition cannot also be a constant, right? A variable has to be something that is varying, right? It takes on multiple different values, so variable cannot be a constant. And this is also not true. A variable cannot occur more than once in an atomic formula. Yeah. Okay. So the correct options are A and B.
Sir, what is well-formed formula?
Formulas. Can I ask?
Sure. So maybe one by one you can ask. So maybe Shyam, why don't you go ahead first?
Okay, sir. Thank you. Sir, actually, from your explanation and from the explanation of the videos, I understood that so atomic formula is a well-formed formula as well as formulas with logical connectives and universal and existential quantifiers. All these three can be well-formed formulas, right?
Yes, so there are three important things in what you mentioned. So one is well-formed formula, another is
Yes,
atomic
sir.
formula, and then there is a general formula. Okay,
Yes,
so
sir.
a well-formed formula is basically something that makes sense, that is not illogical in the way it has been constructed or written. So it has to be syntactically correct, in the sense that if there is an operator, that operator must be placed at an appropriate place between two variables or constants or things like that. Okay, then there is an atomic formula. By the definition that we saw, an atomic formula cannot contain any connectives, not even a negation, not even and or implication. But a general formula can contain connectives. Okay, does that
Okay, in the sense, so like actually the same thing, sir. Even when I'm watching the lecture, there is an ambiguity.
mm-hmm.
Like, what is exactly well-formed formula? Can atomic formula be well-formed formula then?
Atomic formula has to be a well-formed formula. So any
Then
form.
similarly, general formula with assume that all the for suppose if there is I mean I think after negation, if we are having a unary connective, immediately there shouldn't be another logical connective, right? That is like disturbing the definition of well-formed formula, right?
That's right. So what I mean to say is, like the example that you said, if we have something like, let's say, this makes sense. But if we have something like this is not making sense, right? This is illogical. So this is not
Yes.
a well-formed formula. This
Okay,
can
okay.
be said to be. So yeah, like you
So
said,
yes, sir.
yeah. So like you said, there is an ambiguity. I agree. But as we go through the course, as we come across more and more topics, more and more questions and examples, that ambiguity will sort of sink in, and it will get resolved with time.
Um, Actually, not, sir. I don't know like how many registered people are facing this problem. Actually, we if we watch that videos alone,
Mm-hmm.
there is. I mean, what I found is most of the things are written in formula ways rather than like a good examples. Kind of thing like how you explain. But in the video lectures, if you see, just for suppose if you go to that atomic formula slide, just it is written bottom belongs to A and it is an atomic formula. But
Yeah,
somebody if newly registers for this course, it's very difficult to understand because the professor is not at all giving some examples along with that. He is just writing the formulas and going. And
I yeah I
and one more thing, sir. Actually, especially assignment 4. From last 4 days, I have watched that videos twice. I have even written the notes, but still there is lot of ambiguity when we see the questions.
Okay,
I
so yeah, thanks for sharing the feedback, Shyam. So I'll address it one by one. So first thing is about the ambiguity of the concepts and the lack of examples. So so one thing is that this course in itself is a bit ambiguous. Okay, that that
yes,
is
sir.
that is the way this that is what this course is about, right? We're talking about knowledge representation, and there has to be some level of ambiguity to it, and that is understandable. Even when I took the course myself, I felt it was very vague and very ambiguous. But like I was saying before, that as we keep moving forward in the course with time, we will get used to this, and we will start to get develop an intuition as to whenever we are facing an ambiguity right now, that intuition will help us sort of resolve that ambiguity. And I'm 100% sure that with time that ambiguity issue will get resolved, because I myself have experienced that. Okay,
Yes, sir. But
so
one more thing is, I'm really
yeah.
scared of this exam, sir. Even if I want to say that if assignments are of this level, and I can't imagine what could be the level of difficulty of the final exam.
Okay, let
And
me
even
let me address
even when,
let me address the first
even
query that you mentioned. Okay, then we can get back to you. Okay,
yes, sir.
so yeah, first you mentioned about the ambiguity, so I think that I addressed. The next thing
Sir.
is about examples. So with examples, I think so we have some examples in the lecture slides. Other than that, we will be discussing some examples in these live sessions, and we have some practice assignments, right? So I would highly encourage that you make use of the live session as well as the practice assignments. So the aim of the practice assignments is for you to get adjusted to these ambiguities. Okay, so you attempt those, and if you are facing any issues, I would highly encourage that you post your partial solutions. If you have worked out any partial solutions, or if you have any thought reasoning process behind the answer that you arrived at, and if that answer turned out to be wrong as per the practice assignment, you post that on the discussion forum. So
Okay.
that way what will happen is your colleagues who are also taking that trying to answer that same question, it might be that they are also facing the same issues, or it might be that some of them have already addressed this in their mind. So either they will be able to jump in and say that, hey, I try to solve it in this way and this makes sense to me, but what do you think? If not that, the main TA of the course, Bhaskaran sir, he is available. He's very active on a discussion forum. If you can check it
Okay.
right now as well, that I don't think there's a single question that has been left unanswered as of now. Okay, so but he can only help if we have something to, or if he has something to build upon, right? So I would highly encourage you post your reasoning process or your partial solution, so that he can point out where exactly we need to work upon, where exactly are you making a mistake, and then you can use that feedback to resolve your understanding or improve your understanding. Again, attempt the practice assignment, and that will help you in the final graded assignment. Now, coming to the third point you had raised about the difficulty of the exam. Okay, so
Sir.
one thing that I can guarantee is, if you are able to understand the practice assignments and the graded assignments, you will not face much difficulty in the main exam, because the main exam will be following the exact same pattern of, or the exact same level of difficulty of questions that is in there in the graded assignments and the practice assignments. Okay, so you
Okay.
just have to put your effort in understanding understanding to very fine grained details the graded assignment and the practice assignment, and that should prepare you quite well for the final exam. Yeah, so now if you have anything else to add, please feel free.
Sir, if you can do so you are teaching very well for the previous year questions, and your explanation is really good.
Thank you.
And so the same thing, sir, we are not expecting any direct answers from you, but rather than that, if you go to the current assignment and explain us the question, I think it will be helpful, sir. For example, if I go to week 4 assignment of current going course, there is a question, if I go to the first question, there is some data given, set of predicates, set of functions, and set of constants kind of thing. And they asked us which of the following is a well-formed formula in this LPFC kind of thing.
Yes.
So rather than these old questions are definitely helpful to us. Apart from that, if you can take a current assignment, and we don't need answers actually. Rather than that, for example, if you take the term well-formed formulas, and if you can exactly explain what is a well-formed formula, and I think that will be helping us in solving the assignment more, sir.
Thank you for your point, Shyam. I understand, but I
Sir.
still feel that even if I try to explain the question, it would not be ideal, because so see, not all of the registered students in the course attend the live sessions, right? So if I'm
Yes.
able to, even if I'm explaining the question, I am still
Sir.
giving you some sort of hints on how to address that question, right? And it would be unfair to those people who are not watching the live session or not attending the live sessions. And that is not even the major point. The major point is for you as registered students to try to understand these apparently vague questions by your own. Okay, so you have to develop that intuition so that you can try to answer these questions that are appearing to you ambiguous right now or difficult right now. Eventually the goal is that you will get used to it, and you yourself will be able to understand it and explain it to someone else, right?
Yes, sir. Actually, I got that point. Why I asked this is, I know, I even felt that is something unfair. Why I asked this is because I already mentioned that during the lecture in the videos, if there are some live examples similar to the terms, there used not be much difficulty.
I
So like
I
if a
understand,
student
Shyam.
just studying the formula and suddenly like if you ask for triple integral or multiple integrals in the exam, then it is really difficult, sir. And moreover, you can understand that NPTEL courses, most of the students as well as working employees register. So it is like almost what we feel is like every day, or it is like taking a real subject where we attend going to the class, going to the college daily. So
Yes.
you can understand, right? We don't have that much time once we get back to the home, hectic after the office, and if we want to do that detailed thing, then that's very difficult for us, sir.
I
That's what I
understand.
asked. If you
I
can explain that, for suppose, what do you mean by well-formed formulas? Because I really like, I think few colleagues, those who are attending this session, supported me. Lot of ambiguities, sir. Just writing the formula, and now you told me like what is well-formed formula, but there in the lecture there is no particular definition for well-formed formula. It is written well-formed formulas as like A belong to T kind of thing.
yes.
Then you can understand like, and I also agree that in the due course we will understand like how to solve these assignments,
Mm-hmm.
and about the subject knowledge is okay, sir, but we also we should balance the assignment marks, right? And best of 8 assignment marks has will be taken into consideration. And
That's right.
at end of the lecture, we will be getting knowledge. I agree, but apart from that, we should also maintain that assignment marks. And so.
Okay.
I even have seen the statistics. Only 10% of the people are able to qualify, but still I have opted this course in the sense I really have the interest to get a certificate as well as to learn. So I should balance the both. That's what I'm asking you. So if you can help me, then that will be a really good thing for me, sir.
I understand your point, Shyam, and all of these are valid points from the point of view of a student. But I will again
Sir.
like to re-emphasize that so there are two major, sort of factors that you need to balance out. One is the understanding part, and then another is the grading part, right?
Yes.
And like you said, that many of you don't have enough time, to go through everything in a fine-grained detail and then answer the assignment, which I understand, I relate to that. But then there has to be a balance between the time we put in understanding something and the payoff that gives us in the terms of marks. Okay, so if we are putting x number of hours into understanding something, the amount of marks we will get will be proportional to the number of hours we're putting in understanding a particular concept, right? And
Okay.
it is okay to take time to understand something unless there is a really a time bound deadline that you have to fulfill, and that some of the deliverables are highly dependent on the marks or something, which is a different aim altogether. Okay, if the aim is to only get a good understanding of the subject, then I would say it's okay to take as much time as you want to understand the concepts and ask as many questions as you want during live sessions or on the discussion forum, preferably on the discussion forum, because there the
Yes.
scope of addressing is much higher than the scope of addressing it in the live session. Okay, so
Okay.
I'll still maintain my stance on not discussing the questions until the deadline of the assignment is there. Once the deadline of the assignment has passed, we can have a full blown discussion on the question and the answer. That I am more than willing to take part in.
Okay,
Sir,
sir. In
good
this,
evening, sir. Sir, sorry to disturb you. Good evening, sir.
Yeah.
In connection with what sir said, sir, at least if you could explain, see, this week's thing is first order logic. So at least if you give introduction about that and then starting discussing with the previous year question paper, at least we will find, understanding to solve the current assignment. At least that part. So and as sir said. There were no examples and connectivity between the differences over PL and FOL. So, if live examples with those differences, so if flow connectivity is there between the different logics, it would be better for us to understand, sir.
I understand your point, Maithili, as well.
Yes.
And this is something that has actually been they're coming up in previous semesters as well, and I have previously communicated this feedback to the team. Okay, both to professor as well as at main TAs as well as to the NPTEL team, that students are expecting more examples. Okay, and yeah, so I'm not sure if they are in the process of refining the course, whether it will be refined in the next iteration of the course or not, because that is an aspect of the course I am not involved in. Okay, my responsibility as a live session TA is to focus on problem solving, right? I agree that we can take out some time to explain some concepts, and that is what I think I am trying to do, in the sense that, let's say when we discuss atomic formulas, we go back to the lecture slides, look at the specific mention of atomic formulas in the lecture slides, go through that and like try to understand that, and then come back to the questions and answer the questions. So that I think is more practical in the scope of the live session that we have, rather than going through whatever has been discussed in the video again and then going to the problem solving, right? So to the point, to answer the point that both Shyam and you mentioned, uh, about the ambiguity, so again I would emphasize that do not hesitate to post questions in the discussion forum. For example, when you're watching the lecture video, you come across a term, let's say well formed formula, that you don't find any other explanation for, right, anywhere else in the in the video or the lecture slides. Immediately you post that on the discussion forum. You can even mark it as urgent, say that this is urgent, I am not able to understand the meaning of this particular phrase, please help me or point me to appropriate resources. Okay, you can even look at the resources mentioned at the in the details of the course, so I can even point that out. Maybe give me a second. So in this about the course section over here,
Yes, sir.
there will be a set of references given. Okay, there will be.
Okay.
So I think this is a book written by Professor Khemani himself, and that is, I think, mostly followed. Other than that, there is this book by Brackman, and that is also dealing with knowledge representation and reasoning. So you should make use of these resources as well. Okay, of course the video lectures that are available on NPTEL, those are also available for, I mean, they have a limited time frame, right? They have, let's, they're what, like 20-minute 40-minute videos, and it is not always possible to cover all the length and breadth of the contents of a particular topic, as well as the appropriate number of examples that should be given in that course. Of course I agree that examples always help. I myself have always felt that, and yeah, like I said, I've also communicated that to the team. Whether they integrate that, when they integrate that into the course, that is something out of my control, unfortunately. So yeah, what I can do from my side is yeah, point you to these resources, point you to the discussion forum. Let me actually go to the discussion forum and show you some examples. Okay, so see, for example, people have asked these different questions, right, and all of these have received some sort of an answer by by Mr. Bhaskaran, who is the main TA of the course, right? So again I would say, do not hesitate to ask. This is something that I have experienced as a live session TA in the past 3 times that I have taken these live sessions in the past 3 semesters, is that many of the students are unaware of the existence of the discussion forum, so they are not able to utilize it to the full extent. I think Shyam, you yourself have asked this question, right? So that's great to see.
Yes.
So I see some other of the regular attendees as well. I see Khalid's name over here. That's great to see. So yeah, I would highly encourage all of you to make the most use of this, and whatever is remaining, let's keep it in the live session. So the brief that I have always received from the NPTEL team is that the scope of the aim of these live sessions is to help the students you develop efficient approaches to solve different problems, right? Efficient in the sense, the approaches that require less time, less effort, and also they make sure that we arrive at the optimal answer at the end of the solution, right? So that is the main aim of the live sessions, problem solving sessions, because these are named problem solving sessions. Of course we can go into discussions of some specific topics where I can try to explain some things. If they're associated with the questions that we are discussing, that will be perfect. If they are not associated with the questions that we are discussing, for example, let's say you come across a specific topic in the lecture videos that you didn't find an appropriate explanation for in the lecture videos, you also couldn't get enough help from the discussion forum, and you also couldn't find enough help from the books, the other resources mentioned, then again I would like to mention that you post this query in the discussion forum, label the heading as needs to be discussed in live session, right? So let's say for example there is some concept, let's say sentences in first order logic. Okay, let's say someone doesn't fully get that. If you post that well within time, let's say, then I will make a note of that, and I will make sure that we dedicate some time to discussing that specific topic in the next upcoming live session. That will also be beneficial for the student as well as me, because that will also give me the time to brush up my understanding of that subtopic so that I can explain it properly to the person who has asked the query. Does that sound good?
Yes, sir. Thank you very much.
Sure,
And
sir. Thank you.
one last question is like, sir, I feel that all the sentences can be well-formed formulas, and vice versa may not be true. Sir, is that correct, sir? Is that inference correct?
Yes, so all sentences have to be a formula. A formula has
Well-formed
to be,
formulas.
yes. So by definition, a formula, if because a formula has to be a well-formed formula. If it is not well-formed, we cannot even say that it is a formula, right?
Okay.
So any formula, sentence. So yeah, let's go in a recursive manner. Sentence, general formula, and atomic formula have to be well-formed formulas. But
Yes, sir.
whenever we have a well-formed formula, whether that is an atomic formula, whether that is a general formula, whether that is a sentence, that is something that we need to look further into and see whether that can be categorized as an atomic formula, a general formula, or a sentence, based on the definition of these three concepts. Does that make sense, Shyam?
Yes, sir.
Okay, great. So
Sir, one question, sir.
yeah, maybe
Sir, if alpha is not a sentence here,
yes.
then then A will be correct or not?
If alpha is not a sentence here, if it is not a sentence, if it is only a formula, then there is no
Then a
necessity.
variable X must necessarily be in the scope of a quantifier.
Yeah, then in that case that option will not have to be strictly followed, because it is only that we need to have, we
That means,
don't
sir,
we
my
don't want.
question is, without using the quantifier,
Yeah,
can you use the variable in a formula?
in we can actually do that, and we'll see some examples of that in the upcoming questions.
Okay, sir.
Okay. um, Whether that will be a sentence or not, that is something that will be dependent on
That
whether
means
it
in
is.
a well-formed formula, can you
Yeah.
use a variable x without in the scope of a quantifier?
Yes, I think so.
Yes or no?
I think so, yes.
Yes, sir. Can you use x without the scope of a quantifier? If it is a well-formed formula, not a sentence.
Yes, I think so.
Yes, sir. That was my doubt.
Yes. But
That means we can
again,
use x. Huh?
yes, but again, I would encourage you verify this from the discussion forum.
Okay, sir.
Okay, you still post this query on discussion forum and say that this is my understanding, is this correct? So that will also verify whether I have a correct understanding. Okay.
That means that for a well-formed formula only we have to check the it if it is syntactically correct or not.
Yes.
We will not go for the semantically. What does
No.
semantically it may be wrong, but syntactically it will be correct for a well-formed formula.
Yes, so semantic is not coming anywhere in first order logic as of now. We are not dealing with the meaning of sentences at all. A sentence could say that a person, let's say, Raju is a good boy. This could be a sentence in first order logic. It could have a meaning that is completely different from the usual English meaning that we know it to be. Raju is a good boy can in fact mean that fish lives in the sea. So I know this sounds absurd, but that's what think from the point of view of a computer machine, right? Whatever we feed into the computer machine, it doesn't know the English language, right? So it will only work with the variables, the constants, and the functions that we supply to it. So semantic is not something that we need to worry about. We need to worry about syntax and the definitions that make different concepts like term, formula, atomic formula, sentence, and so on and so forth.
So what is free variable and bounded variable?
We will
So
see that in the next couple of questions. I think that will address this query. Okay. And I think, Khalid, you had a question before we had this discussion. Would you still like to ask that, or is it resolved?
Yeah, mostly resolved, but simply you can pronounce a formula. Will the output of a formula generally is it true or false? Is it so, sir?
Um, yes, we can say that. Um, yes, I can. I think we can say that. But yeah, as per my understanding, we can say that. But again, like I said before, I encourage you to
Actually,
verify this.
I understood that, like that. I like that only. But if you can clearly say yes, then it will go in my mind. Like that's why I'm asking.
See, as per my
Formula will
understanding,
tell.
I think it is what it is correct that we can give
Okay, I see.
truth value to it. But I'm still saying that like I am also a student like you, right? So I would encourage that you also verify this through
Sir,
the discussion forum,
sir,
so
sir,
that there is
sir,
no scope of any
sir,
issues in the final
sir,
time when you
sir.
attempt the assignment or the exam.
Yes, sir, yes, sir. Thank you, sir.
Okay. Okay, so I think we digressed a lot. Let's come back to the questions that we have. Okay, so yeah, so this will, I think, at this question 5 will address some of the queries about free and bounded variables that some of you have raised. So let's go through the question. The question says that let father and coach be function symbols. Okay, so father and coach represent functions. Tall is a relation symbol, okay, which basically means a predicate. Tall is a subset, let's say, of the domain. Sneha is a constant symbol, okay, and this is the language that we have. Then which of the following are the sentences in first order logic based on the definition of a sentence that we just saw? So I'll actually let you think through all of these. You can post your solutions in the chat box, and after a couple of minutes we can go through each of these options one by one to see if they are a sentence.
Sir, I think E, F, and G could be definitely sentences.
Okay, so we have a vote for E, F, and J, E, F, and G. What do the others think?
CEG, sir.
Okay, so we have a couple of votes for different possible combinations of these options that we are given. Let's go through the options one by one. Okay, so the first one is tall father X. So do you think this will be a sentence?
No, sir,
No. And what is the reason?
because there we
There's
have
no
an
quantifier.
That's right. Basically, this X variable, this is free. Okay, it is not quantified. So this can take any number of values, any random values. This may be a formula, but this is not a sentence.
sir, that I was asking.
That's right. Yeah. So yeah. So I think this question is
Sir,
like.
it may be a well-formed formula, but not a sentence.
That's right. Yes.
Yeah.
So then,
That I
sir, is formula cannot be semantically right? It could be
No,
as ma'am's
it
one of
can
the
be or it can be.
syntactically.
So we.
Syntactically, it should be correct, but not may not be semantically.
So what do you mean by semantically? Like
Semantic means meaning.
meaning, right? So
Yeah.
here the meaning seems fine to me, right? I don't think this is semantically incorrect. This basically says that
No,
for some
what
x, for some variable
what it
x,
means, what x means here.
that's what
There's no.
x
Uh,
is a variable, right? So we don't
uh,
know that whether x takes a specific value. Okay.
yeah. Yeah.
What this whole formula tells us is that there is some variable x, father of x falls in the subset of tall people.
Tall people.
Yeah, so it's still making sense to me, but we cannot call it a sentence because x is not bounded.
Quantified.
Yes.
Bounded.
Okay.
Your X is free.
X is free.
Yes, it
Yes.
is. Yeah.
Okay. So for that reason, A is not a sentence. What about B?
12 items. Yeah.
Remember, Sneha is a constant symbol.
Sneha's father is tall.
Yes.
So here constants are involved.
Mm-hmm. This is in a
Function
similar.
is also there.
That's right. This option A and B are similar in the way they are constructed. The only difference is that here we have x, here we have a constant.
Variable, here constant, yes.
So in B, if we don't have a if we don't have a variable, the question of the variable being free or bounded doesn't come up.
Okay,
Right.
yes. Yes, sir.
So can we say that this is a sentence?
We cannot exactly tell.
We can tell.
Unsure. Sir?
We can say that this is a sentence because
Oh,
this is a formula. Okay, the formula is making sense.
okay.
Because there are no variables here, we don't have to worry about that variable being free.
Okay, okay.
Okay, so it isn't the case that a formula always has to have a variable. It might be that a formula doesn't have a variable. Even in that case, it can be a sentence if it is a properly constructed formula.
This way only we are finding it ambiguous, sir.
Yeah, so
This is the problem.
I
So B is
understand.
correct. So B is correct, sir.
Yes,
B is a
Yeah.
sentence. Okay.
so I understand your point, and I, like I said, when I was a student, I went through this, and I also faced difficulties. I felt that it is quite ambiguous. I communicated it to the team both as a student as well as a TA, and based on
Okay.
my experience both as a student and a TA, trust me, it gets better with time. Okay.
Actually, like this with an example, if deriving the concepts, if in that way, if this course is being constructed, maybe it would have been beneficial for us
I
to, as a student.
Yeah, I think so too. And
Mm.
like I said, we have communicated that maybe till the time they refine the course, we can rely on these sort of examples that we discuss in the
Yeah,
live
yeah,
session or through the
exactly.
practice assignments.
Okay.
Okay.
So with these example, we could able to understand we don't have variable, so why to worry? Either it's a bounded one or free. So
Exactly.
this part of sense it is not there in the course flow. So that is what the thing.
I
We
I
couldn't able to recognize,
I
yeah,
understand,
realize the
but
things.
these live sessions are also part of the course. Like they are not independent of the course, but they are supposed
Yeah,
to be
yeah, yeah.
supplementary to the course. So yeah, you can make full use of the discussion that we have over here.
Sure, sure. Thank you, sir.
Okay. So let's
C,
come.
C, third option.
Yes, let's come to option C. So what do you think about this?
Here
Yes.
also,
X is quantified, but X is not used in the formula.
yes.
Yeah, we have a quantifier, but x is not used in the formula. But because x is not used in the formula, we actually don't have to worry about the variable.
Quantification, yes.
Okay.
In
So that
fact,
is also right.
look
So
at.
we can say that it is a sentence.
Yes, so we have to just think about whether this falls in the definition of a formula. And to see whether this falls in the definition of a formula, we have to see whether this falls in the definition of atomic formula, and whether, if to check whether it falls into the definition of atomic formula, whether we have to check whether it falls into the definition of a term. Okay, so there is a recursion. To check a sentence, we have to be sure whether it is a formula. To be sure it is a formula, we have to be sure that it is following the definition of atomic formula. The ingredients of the formula should follow the definition of the atomic formula. Again, in recursion, the ingredients of the atomic formula should follow the definition of a term.
Yeah.
So here we have two ingredients. One is father of Sneha and another is tall Sneha.
Mm.
So do both of these represent atomic formulas or terms?
Yeah, terms.
Let's go back to the definition and check.
Father is function, tall is a predicate.
Yes. So we know that the term, if it's a variable, it's a term. If it's a constant, it's a term. If it's a function, it's also a term.
Yes.
Okay. For atomic formula, um, if it's a term, if it's true or false, it's an atomic formula. If it's the equality of two terms, it's an atomic formula. If it's a predicate that contains a certain number of terms, then it's an atomic formula.
Yeah.
And
But
then,
function is not mentioned.
yes, and for a general formula they have to be connected by uh, and or some other
Connectives,
connective.
logical connectives. Yes.
This is the way we have the constructed sentence, the constructed candidate sentence given
Form.
to us. So
Okay.
we want alpha and beta both to be formulas. Okay.
Mm.
So
Yes.
if we go back to this one, we want father sneha to be a formula, we want tall sneha to be a formula. So let's again go back to the definition that we have. Okay.
Alpha
And
conjunction.
Yeah, it's both are formulas.
both are formulas.
Yes, predicate and function, both are formulas.
Okay, are you sure?
Mm.
So tall of
So this,
sneha is
are
for
you
sure.
telling it's a formula or atomic formula?
um okay, so
It's
for
a
it
formula, but not atomic.
okay, so alpha and beta has to be a formula. Okay,
Mm.
for alpha and beta to be formula, alpha comma beta should belong to the set of formulas.
Formulas.
So we have to check whether alpha and beta are formulas independently. Okay, in our case alpha corresponds to father of sneha and beta corresponds to tall of sneha.
Mm.
Okay, let's look at tall of sneha first. As per the definition of a formula, of an atomic formula, of a formula, let's say, for alpha to be a formula, if it is an atomic formula, we can say that it is a formula. Okay, so we now have to check whether tall of sneha is an atomic formula.
Yes.
Okay,
Predicate of term.
yes, predicate of term, so it is an atomic formula. So we know tall of sneha is an atomic formula. Because tall of
Yes.
sneha is an atomic formula, it is also a general formula. So
Yes.
that part is resolved. Now let's look at what was the other part?
Function.
Father of
Father of
Father
sneha.
of Sneha.
Yes. Now let's go back to the definitions that we saw. So there are these four conditions for us to have atomic formulas. Okay, either it has to be true or false, or it has to be exactly in this framework where we have an equality of two terms, which we don't have in the example given to us, or it has to be a predicate within a term within a predicate, right? But what we have is a term within a function. So function, so what we have over here, father of sneha, this is basically function, and this within the bracket is a constant, right? This is a term,
Yes, sir.
but it is not an atomic formula,
Okay.
right?
Yes.
Yes.
Because the
So, in
definition
the
of
sense, individual, I mean, parts of all your, what is this? This has to be a formula, sir, not atomic formulas.
okay, so it has to be,
I mean, all atomic formulas, if a formula, it has to be atomic in nature. Is that so?
if we have a formula, then the ingredients of that formula have to follow the definition of a formula. Okay,
Okay.
so for, like I said, alpha and beta, so both alpha should be a formula and beta should be a formula. Okay, for alpha to be a formula, so alpha is not connected by any connectives anymore, right?
Mm.
So the only condition that fits is if alpha is an atomic formula, then we can say alpha is a formula.
Okay.
So because of this, now we have to check whether alpha is an atomic formula.
Okay, okay. So atomic formulas connected with logical connectivity, it could be a formula.
It is a formula.
Is that so?
Yes.
Okay. Okay then. Okay.
Atomic formulas connected by connectives will always be formulas as long as they are well formed.
Okay. Okay.
Okay. And like we discussed, a singular term alone cannot be called an atomic formula. Okay, it has to be either connected by this equality or it has to be an argument to a predicate. And that is the reason why father of Sneha, this is a term but not an atomic formula. Because it's not an atomic formula, we cannot say that this is a proper formula. Because this is not a proper formula, this is not a sentence.
Yes. Sure.
Okay, so C is incorrect. Okay, now let's look at option D. Again, we have a quantifier, but we don't have any variables within the formula, so we don't have to worry about the scope of the variable. We just have to look at whether this is a properly formed formula.
Okay.
What do you think about option D then? Is it a sentence?
Father is a function.
Father is a
Tall is a
function.
predicate.
Yes. Think
So
about option.
Sneha's father is a
Sneha's
subset of tall.
Think about option B. It's exactly the same, right?
Yes, sir.
So if we
only quantifier is
yes,
there.
But that doesn't make sense, that quantifier. So
It's a
need
sentence.
not worry about. Yeah, it's a sentence.
it's a sentence. Correct. Yeah, we have a quantifier, but there is no variable within the formula, so we don't have to worry about the scope of it. This we know is a proper formula and a sentence, tall father Sneha. So this is the whole sentence D is also a sentence.
Okay.
Okay.
So in the sentence D, instead of for all x, when I mentioned, there exists x.
Yes. Even
There
in that case,
exists
it will be a
x.
sentence.
In that case also.
Yes. If we didn't have a quantifier and we had x within the formula, then we would run into a problem because then that variable would not be bounded. Okay. Now let's look at option E.
Sentence.
Sentence.
It's a sentence, proper sentence.
That's right. This is a proper sentence, fits all definitions. We have a quantifier, we have a variable within the formula.
Yeah.
This is a tall is a predicate. Within the predicate as an argument, we have father of x. This is a term, right? So this is an atomic
Yes.
formula and it's also a formula and it's also a sentence because this x is bounded by this quantifier there exists. What about option F?
Sentence. It is also sentence.
Coach of X,
Remember
who is also father.
Remember, father is a function, so will it be an atomic formula?
Father can also be a coach, na sir?
Father is a function.
So, like I said, don't worry about the English word meanings of these. Father is a function, coach is a function.
It is not a
Coach
it is
is a
not a
predicate.
No, coach is a function.
Function.
Both father and coach are functions.
Okay.
But is this an atomic formula? Father of coach of X?
No, no, sir. It is not a atomic formula.
Exactly. It's a term.
Yes.
Okay.
Yeah. It's a term, but it's not an atomic formula.
Formula. Okay.
So, F is not a sentence. And finally, we have option G. This also has a quantifier, it has a variable within the formula, it has a connective, and both the ingredients of the formula are also Atomic formulas.
Atomic formulas. Yes.
So G is a sentence.
Yes.
So these are the final answers that we have, and I'll leave this slide over here for a minute or so that you can convince yourselves, and then we'll move on to the next question.
Sir, option C, can you explain once more, sir? A little bit, I feel ambiguous.
Sure. So um, in option C, what we have is, so first so let's look at it from left to right. Okay. First we have a quantifier, this existential quantifier. Okay.
Yes, sir.
So we would first look at whether the rest of the formula contains any occurrence of the variable. But it turns out
Okay.
there is no occurrence of the variable. So we
Okay,
don't
sir.
have to worry about whether that variable is free or not. So that issue is not of a
Yes,
worry to us as of now.
that is very good.
Okay. Now let's look at the formula part of it, whether we can say that this father Sneha and tall Sneha can be said to be a formula. Okay. This can be represented by alpha and beta, right? Where alpha is
Yes, sir.
father of Sneha, beta is tall of Sneha. Okay. As per the definition of a formula, if alpha comma beta both belong to the set of formulas, as in both
And conjunction belong to formula.
so if alpha is a formula as well as beta is a formula,
Yes.
then and connected version of that will be a formula. So
Yes,
now
sir.
we have
That
to,
understood, sir.
yeah, so now we have to understand whether alpha is a formula and whether beta is a formula.
Yes, sir.
Okay. Now if we look at alpha individually, alpha does not have any more connectives, right? Neither unary nor a binary connective.
Yes, sir.
So the only way for us to check whether alpha is a formula is this condition. First one, that is, if alpha is an atomic formula, then alpha is also a general formula.
Okay.
Okay. Now we have to check whether alpha is an atomic formula. So let's go to the definition of atomic formulas. Now let's see whether alpha falls into any of these conditions. Okay.
Okay.
The alpha that we were given was father of Sneha. Okay. Sneha is a constant, father is a function,
Function.
right? And
Yes,
we
sir.
know from the definition of terms that if we have a function,
Yes,
function
sir.
takes terms, that function containing term will also be a term,
Yes, sir.
right? So we have Sneha going within the function as an argument. Sneha is a constant and constant is a term based on
Okay.
this condition. So function of constant, father of Sneha, that is a term.
Is also term.
Yes. So it's a term, but is it an atomic formula? That we have to check. Neither of the conditions that are mentioned over here say that an individual term is an atomic formula. Only when two terms are connected by this equality, we can say that it's an atomic formula.
Okay.
Or if a predicate contains individual terms, then it can be called an atomic formula. So, father of Sneha is not an atomic formula.
Because it contains function.
Yeah, because essentially it's a term. It contains function,
Okay.
yes, but it's a term. So we
Okay.
have basically a term and atomic formula. Because of that, it is not falling into the definition of a formula, and hence it's not
Okay.
a sentence.
Anyhow, actually, if we can tell that father of Sneha is not an formula, we need to check the other condition, right? This is called a short circuit case.
Exactly. If we
Yes, sir.
already know that father of Sneha is a term and it's not falling into the definition of a formula, we don't even have to look at this part. We can straight away say that this is not a sentence.
Yes, sir.
Yeah.
So in turn, can we tell a sentence doesn't involve functions alone? Predicate of function is allowed, but function term is not allowed in sentences. Is that so? Is this
Yes.
the understanding? I'm not sure.
Yes. So we can have, like you said, function.
Predicate. Yeah.
Yeah, only when it is an argument to a predicate, Or
Yeah.
if it is an equality of two terms, then we can say that it is an atomic formula and hence a formula, but not
Okay.
otherwise.
Yes, sir. Thank you.
Okay.
Sir, if it is the case that if I want to check how many of these are well-formed formulas, then how to do that?
So for that, again, you have to follow a recursive fashion. You have to break down the sentence into its individual ingredients.
Okay.
Check if each of them are individually well formed.
Uh, okay.
Okay.
So, like as we discussed earlier, can I argue that all the sentences are well-formed formulas,
Yes.
or should I still go for verification?
All sentences have to be well formed formulas.
Okay, okay, sir, got it.
Yeah.
So can you explain any one of the option that it's a well-formed formula? One sentence.
All of these actually are well
Maybe
formed
G.
formulas.
Uh,
If let's say instead of this, let's take option C only. Okay. If instead
okay.
of this and here we had, let's say, a negation. Okay. In that case, that wouldn't make sense. That wouldn't be well formed because between two ingredients, there should be a binary connective, not a unary connective.
Okay.
Okay. So that
Yeah.
would be an example of a not well formed formula. Okay.
Sir, you want to say that there exists a negation of father of Sneha and tall of Sneha
No.
cannot be well-formed formula, right?
No, I am meant to say there exists father of Sneha, negation of tall Sneha. So we are replacing this and by a negation. That would make it a not well formed formula. If we have a negation before father of Sneha, that will be a well formed formula because that negation would be applicable to only this part, father of Sneha.
Okay, okay,
Okay.
okay, sir.
Okay.
Yes, C is the well-formed formula, but not a sentence.
Yes.
Hmm.
Okay. I
Sir,
think we have spent enough time on this
sir,
question.
sir,
Let's.
just one
Yes.
question.
Yes. Go ahead.
Just a simple thing.
Mhm.
Father bracket Sneha. What is that?
It's a term.
Yeah. So it is not a function, right? Sir? So in the question C, simply father is a function.
Yes.
So I can say x square. It will give a valid term. Say for example 4. 4 and conjunction or disjunction. Number 2, tall in brackets. Yeah. So we cannot add a relation something like that between two terms. So the
Can
actual
you
problem is
can you come again, Khalid? I don't think I got your question.
yeah. Father Sneha number C
Okay.
and tall bracket Sneha.
Yes.
These two inside are giving actually values 4 and 2, 3 and 4, something like that. But we cannot use a word. So we cannot use a relation between these two terms like and. That's why it is falling. Failing to become a sentence.
Um, you can think of it that way, but I wouldn't try to assign values like 3 and 4. The only values it can take is true or false because we are dealing with a logical case, right?
The father Sneha will a function will give you a term only from the domain. It cannot give the true or false. We cannot add a relation like and between two terms. That's why C is a false.
So here we are trying to put a connective between a term and a atomic formula. That
Yeah,
cannot be
that's why
done.
it is a
Yes,
sir.
that's why it's not a formula.
Sir,
Yeah.
sir, okay, right, sir. Done, sir. Done, sir.
Okay. Okay, let's move on to the next question then. Question 6. Again, we have to, it's the same setting. Father and coach are function symbols. Tall is a predicate. Sneha is a constant. And we have to decide which of the following are sentences. But here, all of these have been connected by an equality. So we have to decide which of these are actually sentences. So again, I'll let you try to work it out and then we'll discuss it.
CEF, sir.
Correct. B is correct.
B. CEF.
B is correct. B, G. B, G is correct.
Okay, so we have a couple of votes for different possible solutions. Let's look at, let's say the first
Eva
option.
also could be right, sir. Father of X could be coach of Snake.
B, E, G.
Oh, but X is not quantified.
That's
A
right.
is also.
That's right. So this here we do have X to be free. Um, can one of you please mute yourselves unless there is a question? Yeah, thank you. Um, okay, yeah. So because X is free, we cannot say that this is a sentence. Okay, so A is not a sentence. What do you think about all the other options? B, C, D, E, F, and G.
C, there exists X,
Mm-hmm.
whose coach, sorry, father of Sneha could be a coach of X,
Mm-hmm.
uh, where X exists.
Yes. So here
So
X.
that's right.
Yes, that's right. X is in the scope of the existential quantifier.
Yeah.
Both the left hand side and the right hand side of the equality are terms, and two terms connected by an equality is an atomic formula. So
Yes.
it is a formula, and it has no free variable, so it's a sentence. So in fact, all the other options B, C, D, E, F, G, all of them are sentences. Only A is
Yeah.
not a sentence.
Yes.
Yes. So let me go to the solution then. Yeah. So only A is the incorrect one. All the others are sentences of first order logic.
Okay.
Okay. Shall we move ahead to the next question then?
So is that the meaning that father of Sneha, I mean, same person can be father and coach, sir, for Sneha?
For which option?
B. Father of Sneha equal to coach of Sneha.
That's right. Yeah. What is trying to convey is that the person or the entity that represents the father of Sneha is equal to the entity that represents the coach of Sneha.
Oh, there is a possibility that this father could be a coach also.
Yes. This B itself total is an atomic formula. Okay, so this will have a truth value now. It can be
Okay.
true, it can be false.
Okay, fine.
Yeah,
Thank you, sir.
sure. Okay, then let's move to question 7 now. So now we are done with sentences. Let's move on to next part of the things that were discussed in week 4. One of them is interpretation. Okay, so this is again a sort of a recall based question. Okay, so an interpretation, so this symbol just means I, it's a fancy way of writing I. Okay, equals to, this D represents a domain, I represents an interpretation of a first order logic language, LPFC. An interpretation unambiguously, note the emphasis on unambiguously, determines the truth value of which of these options. So an interpretation would unambiguously determine the truth value of which of these.
Sir, a small doubt regarding the previous question, if I can ask.
Yeah.
Sir, So can I say that all the tautologies and contradictions can be well-formed formulas as well as sentences?
Um, I need to think more on that. By tautologies as well as contradiction, we are kind of covering everything in existence, right?
Yes, sir. For example, let us take a tautology.
Okay.
Can it be a well-formed formula and thereby can it be a sentence?
See, if we are assigning some truth value to it, I think it should be well formed. Because if it's not well formed, it doesn't make sense to assign any truth value to it. So, by that sort of reasoning, yes, any formula that has a truth value assigned to it should be well formed. Does that make
So
sense?
tautology can be a sentence, right then?
Can be, yes.
Okay, sir. Thank you.
Okay. Okay, what about question 7? So, like I said, focus on unambiguously. So, the set of options given over here, they are different in terms of whether they include free variables or not. Whenever we have free variables, can we unambiguously determine the truth value?
No.
No, that's right. We
No, sir, we
cannot.
cannot.
Yeah,
So
because
A is the correct answer.
yes, A is
A,
correct.
C.
Formulas with terms from only from for the set of formulas and
C.
constants.
C is
And
also right.
C is
And
also correct.
Bound variables and constants.
that's right.
Bound.
Because
Yes.
options B and D both have free variables in them,
Three variables,
we
yes.
cannot use them to unambiguously determine. So the correct options are A and C.
Okay.
Okay. Okay. Great. Then let's move to question 8 now. So here we are dealing with unification. Okay. And before discussing this, I would like to go over the rules of unification so that it will be easier for us to answer this question. So, where is that? Okay. Does anyone remember the page number where we have unification? Ah, it's over here. This is supposed to be a slide. Yes, this is the unification algorithm. Okay, so basically what we want to do is we want to unify these two formulas. Okay, but there are some variables here and some quantifiers here. So we have to make appropriate substitutions so that the two options given to us become unified or the same as in essence. Okay. So what can we do to unify them? We have to follow some rules of substitution, right? The rules that we have to look at is two constants can be unified or matched or substituted only if they are identical. Okay. Two lists can be unified element by element, building up the substitution as we scan the list. So we look at the first element. If it's unifiable, we unify that. Then we move on to the next element of the list, and so on and so forth. Okay.
Sir, if you don't mind, can you quickly tell the definition of unification exactly?
Sure, sure.
Like rather than going to the slide, just in a
I'll
general way
I'll
by
just
taking
show
some
it with
example.
the help of this example. I think this is a simple example.
Yes.
Okay. Um, so what we want to do is, so we have this normal mod exponents, okay, which tells us that if we have P implies Q and P, then we should be able to infer Q, right? P implies Q and P together infer Q. You agree with me on that?
Yes, sir.
Yes,
I
sir.
agree.
Now let's say we have quantifiers and variables. Okay, so this P question mark X basically tells us that this is basically universal quantifier. Okay, so this tells us
Yes, sir.
for all X, P of X implies Q of X. Okay, X is a variable, and let's say we only know that P of A is true. x can take some different values. Let's say x can take values a, b, c, d, e, f, g, h, so on and so forth.
Sir.
But we
Yes,
only
sir.
know that p of a is true. Okay, so if we replace this variable x with the value a, in that case we would have p of a implies q of a, and p of a is true, therefore q of a is true. Do you agree with me?
Yes, sir.
But we cannot say the same for p of b or p of c or p of d or so on and so forth, right?
Okay.
Right. So what, based on just these two facts given to us, okay, we are reducing the number of steps of derivation that we want to do. Okay, we are formulating this modified modus ponens, which substitutes this variable x with the value a in an intermediate step and utilizes that to infer q of a. Okay, so this substitution is basically what unification is basically what is allowing us to arrive at this particular fact. Okay, so this is one example of substitution, not what I was saying earlier. This is an example of substitution, and a substitution theta is a unifier for two or more formulas alpha and beta. If when applied, it makes the two formulas identical. Okay, now, so this was an example of substitution. Okay, are you with me till here?
Yes, sir.
Okay, now let's say we have two formulas, okay, on the left hand side and on the right hand side. Both these contain some variables. What we can do is we can do some substitutions to one of these formulas, let's say the left hand formula, to make it identical to the right hand formula. That is our goal. Are you with me till here?
Yes, sir.
That is what unification is. We basically do a set of substitutions to one of the formulas so that it becomes identical to the other formulas, and this process of making those two identical is unification.
Sir, if I mean, what, for example, alpha can be p of question mark x implies p of question mark q of question mark x, right?
Right.
And beta is the down one, p of a and q of a, right?
No, so this is an example of substitution, not unification. Let me write
Okay,
it
sir.
down. Write down something that might help you.
Yes, sir. Definitely.
So let's say on the left hand side we have p question. Oh, sorry, I'm not sharing this. Yeah, now it should be visible. Is it visible now?
Yes, sir. Yes, sir. Visible, sir.
Yes, nice.
Okay. Okay, this is on the left hand side.
Yes, sir.
On the right hand side, let's say we have y. Now these two have different variables. Can we make them identical somehow?
So is it the duality? De Morgan's duality in proportional logic?
Not really. So we just want to have some way to make these two identical. Can we replace x with something else to make it identical to this right hand side that we have?
Okay.
So we can replace x by like y, right? Or something like that.
Exactly. So we will perform a substitution here. Okay, x will be substituted by y. So then we will have this. Now left hand side has become exactly identical to right hand side. Okay,
Okay.
this is unification. Now we have to follow some rules to make these substitutions. We cannot just substitute anything for anything. Okay, we have to follow certain rules to make these substitutions. Here we replaced a variable with a variable, so we were able to do that substitution. But there are certain rules that don't allow us to make certain substitutions. For example, yeah, constants can be replaced only with a constant. So we cannot replace variable with a constant and a constant with a variable. Actually, a variable can be replaced with a constant, but a constant cannot be reunified with a variable. So if I go back to the example that we had, let's say here instead of this, we had some constant c. Okay. In that case, we cannot replace c with y. We cannot substitute the constant with a variable. So in that case, we cannot unify these two. Are you with me?
Yes, sir.
Yes, sir.
So with, I hope if that is clear, then let's go back to the questions that the option that we had. So which of these do you think can be unified? I'll just go over the rules of unification again. A constant can be unified only with a constant or substituted only with a constant. For a list, every element by element we have to substitute, and only if they can be substituted or unified, then only we can say that two lists are unified. A variable can be replaced with another variable or a constant or a list, but given that list does not contain the same variable. These are the three important rules, and this is what we have to follow to do the unification.
Sir, can you show me some examples of list, like how to write syntax for list?
List can be something like, how do I say it?
List of n items separated by comma, na, sir? Like names
Yeah, something like that.
or details of a person, like
Yeah,
that.
let's say we have
Separated by comma.
different entities connected by comma or something. I honestly I don't know if there is a proper way to represent a list. I don't think that is covered as of now. Maybe in the later slides. I think at some point we will cover a particular programming language called Prolog, and I think there it will be clearer how to represent a list.
Okay, sir.
Okay.
So in the sense, we got a clue that out of 4 options, we don't have list in this, right?
Yes, that's right.
Okay, sir. Okay, thank you.
Okay, so I'll let you think about it, and after a minute or so, we can discuss it.
Sir, Anisa is a constant, right?
Yes, Anisa is a constant. That's right.
Okay.
All the usual observation that we have seen till now follow. Anisa is a constant. Mother is a function. It starts with a small letter. If it starts with a capital letter, it'll be a predicate.
I think one option can be B.
Okay. So let's look at option A first. Like the example in the example that we just discussed, Anisa is a constant. In order to make this equivalent or identical to this, we need to replace Anisa with mother of Z2, where Z2 is a variable. But we cannot, sorry about that, we cannot represent we cannot substitute a constant with a variable, right? Do you agree with me?
Yes.
Yes,
So
sir.
option A is not unifiable. Okay. I think some of you also mentioned that in the chat box, and that's great. Let's look at option B. Here, Anisa is already identical. The only thing we need to worry about is Z1 and Z2. If we replace this Z1 with Z2, those two will become identical, right?
Yes.
So B can be unified,
Yes, sir.
right? What
Yes.
about C and D?
Yes, sir.
C and D can also be unified.
Yes, sir. C and D can be
Because
unified because
variable can be replaced with variable.
That's
Yes,
right.
sir. Yes, sir.
The function with a variable.
Yeah.
So B,
So,
C, D.
yeah. So the correct options are B, C, and D. Okay.
sir, actually, if you can go to the slide, there is a third one, right? A variable can match a variable or constant.
Uh huh. Or a list.
Variable. Ah, okay. List for suppose let us avoid because you haven't mentioned any list in that.
Yeah.
So a variable can match another variable or a constant, right?
Yes.
So, so in that example, we avoided the first option.
For the first option, we are trying to replace the left hand side. We try to make substitutions in the left hand side. Okay. So here we have a
Okay.
constant. Constant we can only replace with another constant, not with another variable. That's why option A is not unifiable.
So we always go from right to left or left to right,
Left
sir.
to right.
So first we will be starting with negation likes question mark Z1 comma Anisa.
Don't worry about negation as of now. Just
Okay.
try to see if we can make substitutions in the left hand side so that it becomes identical to the right hand side.
Sir, can you
So
explain option D, sir?
Option D.
D, D. The variable.
That's right. So let me go over option A once and then I'll go to option D. Okay. So here we are trying to, we can replace Z1 with Z2. Okay.
yes, sir.
So this will become question mark Z2 over here and Anisa. Okay. But
Yes.
we want to have mother question mark Z2 over here. That we cannot do. We cannot replace Anisa with another variable. Okay. That's why it's not
Okay,
unified.
sir. I know I understood that,
Hmm.
but the thing is like so when this kind of questions were given,
Yes.
first I have to read actually which one. I
Left
mean right side one or left side one.
left one. You have to make substitutions in the left one so that it becomes similar to
Okay.
right one.
So then I should make the right one as the trademark, right? The right
Yes.
one as the standard one, and just I should see like what changes I can make in the left side so that it will be looking identical to right side one.
Exactly.
So right side one, I should take it as a standard one, right?
Yes. Yes.
Okay, sir.
And now
Thank you.
coming.
Option D, sir.
Yes. Yes. Option D. So here we replace Z1 with Z2. Okay. And here we replace X1 with mother of Anisa, which is a constant. Okay.
Okay, okay, okay. Yes, sir.
So we
Yes,
are
thank you,
replacing
sir.
variable with a constant.
There is a function here.
Yeah. Function of a constant will also be a constant, right?
So we can replace a variable with function with a constant.
Yeah. 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 We can do that. See, if it's a
So that
if
is
it's
not in the rule, sir.
I think third rule
Function
is
with
throwing some
constant
light
with
on it.
equivalent variable.
uh, see, we can replace a variable with another variable or a constant. Okay. So mother of uh, Anisa, that is there, Anisa is a constant, so mother of Anisa also becomes a constant, right? So Anisa is an entity, okay, that is a constant. Mother of Anisa, that will also be a constant. That is why we are replacing it with that. If it had been mother of a variable, right, that
Okay.
would be a variable, because like a variable it can take multiple values.
So for that we can't substitute a constant with a variable.
Yes, we cannot substitute a constant with a variable. Okay, then. So let's move to question 9 now. I think we already discussed this. So modified modus ponens, which we just discussed, it combines which two rules of inference? It has to be modus ponens. What else?
Universal instantiation.
That's right. It has universal instantiation because what we are doing is we are replacing the universally quantified variable in modus ponens with one possible instance of the value that that variable can take. So universal instantiation. Okay.
Okay.
Okay, then let's move to the next question. Okay, so now we are talking about scolemization, scolem constants. And for this, I think we need to visit some of the concepts. Let's go to the lecture slides. Okay. So here basically what we have to look for is existentially quantified variables. Okay, and the scope of that variable. So when we have an existentially quantified variable that is not in the scope of any universal quantifier, then the variable it quantifies is replaced by a constant, and that constant is called Scolem constant. Let me explain with an example. Okay. Here in the first line we have there exists some z, some variable z, okay, such that z is a student and z is bright. Okay. So here we have one variable z that is an existential quantifier. Do you agree with me?
Yes, sir.
Yes, sir.
But there is no universal quantifier to enclose the scope of this variable z, right?
Yes. Yes.
In that case, when we do simplifications, instead of writing this there exists again and again, we can replace this z with this column constant. We can call it sk1. We may not call it sk1, we can call it sk100, sk200, sk130, whatever we want. Basically, some constant, and replace this z with that particular constant. That is the concept of scolemization. Okay. The second example is there exists y such that girl y and for all x boy x implies likes x comma y. Okay. Here y is an existentially quantified variable. Y is not in the scope of this universal quantifier over here, but x is. Do you agree with me?
Yes, sir.
So we will replace y with the Scolem constant, but we will leave x to be as it is. We will replace x with question mark x, which is basically simplifying the universal quantifier. So this will become girl sk2 and within appropriate parenthesis boy question mark x implies likes question mark x comma x sk2. This is the case of scolemization when the existential quantifier is not in the scope of any universal quantifier. What if we have existential quantifiers, existential variables within the universal quantifiers? Then what can we do? So for that we will replace it with a Scolem function instead of a Scolem constant. Okay. Again, let's look at an example. Let's say we have for all x, for all y, there exists z. So here z is the existential variable. Okay. Less than x comma z and less than y comma z. So z falls within the scope of both x and y. Do you agree with me?
Yes,
Yes.
sir.
Yes, sir.
So we will replace this z with a Scolem function of the corresponding universally quantified variables. Right? So here x and y both are universally quantifying. Basically, z belongs to the scope of both x and y, right? So we will replace z with a function, let's say sk57, that takes as argument x and y. Does that make sense?
Sir, can you come again, sir?
Sure. So let's take the second example, let's say. Okay. For all x, boy x implies there exists y such that girl y and likes x comma y. Here y is the existential variable, correct?
Yes, sir.
This is within the scope of this universal quantifier for all x. Correct?
Yes, sir.
Now we want a way to replace this existential variable y. Okay?
Okay,
Because
okay. Now I got it, sir.
yeah, so we want so
Instead of writing y, we will try to avoid writing y, and that we will write in terms of x, right?
in terms of a scholen function that contains as
Ah, column.
argument x.
Yes,
Okay?
got it, sir.
Yeah, so that is the basic concept of scholemization. Whether you will replace something with scolem function or scolem constant, that is decided by whether the existential quantifier falls within the universal quantifier or not in the scope of universal quantifier. When it is not in the scope, then we will use scolem constant. When it is within the scope of a universal quantifier, we will use the scolem function, and the arguments of that function will be the universally quantified variables.
So can you explain that first one, sir?
Sure,
Less than x sk57. So that one, can you
sure.
explain once more, sir,
So
please?
here, z is the existential variable. We agree with that,
Yeah, yes, sir.
and it is falling within the scope of which universal quantifiers?
X and Y.
X and Y.
X and y, right? So
Yes.
we want a way to replace z with a scolem function. Okay, what argument should that scolem function take?
X and Y.
That's the doubt.
Yeah, right.
Because here less than x z it is being given. X is less than z, and z is
So
sorry, z is less than x and y. Okay, okay,
yeah,
okay.
so this both these universal quantifiers are before the existential quantifier, if you observe.
Okay, okay,
Okay,
okay,
so they
okay.
cover this whole scope.
Okay.
Okay, if let's say there had been some additional universal quantifier that does not that does not fall in the scope of that, we don't need to include that in the as an argument to the scolem function. We will only include those universally quantified variables that um whose scope includes the existential variable.
But here it is being repeated, no, sir? Less
Which
than x, then column function. That is so x is being repeated again here and y.
Yeah, x can be repeated again. We don't have to worry about x. We have to worry about replacing the existential variable. So
Oh,
y
is it
is
alone? Yeah.
z is being replaced by sk57 x can xy, and z is being replaced by sk57 xy again over here. Y
Okay.
will just be replaced by question mark y and question mark x respectively. We don't need to write the for all x again.
Okay, fine.
Okay.
Okay. So
So this is the
Sir,
concept.
my doubt is assume that if we have an universal quantifier
Yes.
and inside the scope of another universal quantifier, then how
Yes.
to deal the case?
Then you can just replace it with the corresponding question mark.
That's it. No need of worrying about this thing, right?
No, we will have scolemization only when we have an existential variable.
Okay.
okay.
Okay. So now let's come back to the question. So a scolem constant is which of the following? I can give you a hint, only one of the options is incorrect.
Is like
So focus on the definition of a scolem, like when we do a scolem, when we replace with a scolem constant. What is the condition that we need to have?
B only deals with universal quantification.
That's right. We will replace with a scolem constant when the existential variable is not in the scope of universal quantifier. So option
Yes.
B saying that it's different from a constant because it is universally quantified is incorrect. It shouldn't be universally quantified. If it was
Yeah.
universally quantified, we would have replaced it with a scolem function. So only B is the incorrect option. All others are correct. Does that make sense?
Yes, sir.
Okay. That's great. Then we will look at the last question then. This deals with scolem function. A variable x is substituted with a scolem function of variable y. This means that which of the following is correct? And again, I'll give you a hint, only one option is correct.
C is correct.
D, sir. Yeah.
So remember the definition of a scolem function. We will replace an existential variable with a scolem function when that existential variable falls within the scope of a universal quantifier. So here
Yes.
the only option that follows that is
X is X.
x is
C is C.
x is existentially quantified, and that falls within the scope of y. Y has to be universally quantified.
25.
So the correct option is option C. Okay. So that brings us to an end of the questions I had for today. I hope that helps in solving the assignment for this week. And yeah, I think we're also nearing the end of the time we have. Is there any quick question that you have for me? If not, we can close the session for today.
Sir, actually, previously you told that if there is an universal quantifier,
Yeah.
like if there are two universal quantifiers, like in the scope of one each other. For suppose there is an universal quantifier, in that universal quantifier scope, there is another universal quantifier.
That's right.
You told that we need not, we can directly write a question mark of x or y or something, right?
Yeah.
So, but if the same thing, if I can convert that universal quantifier into existential quantifier, then the answer differs, right?
If we have both existential quantifiers, then we don't need to worry, because both those existential quantifiers wouldn't fall within the scope of any universal quantifier. If you replace only one of those two universal quantifiers with an existential quantifiers, then depends on that, yeah, then the answer will change depending on which variable falls within the scope of what variable. Does that make sense?
So, so then how to answer the questions are then. So for suppose if I have two universal quantifiers within the scope of each other, one way is directly, as you told that directly I can mark the answer
Here you
just by
see,
replacing the question mark.
here
So
see,
another way is if there is a possibility of changing one of the universal quantifier into existential quantifier by using the rules of inferences, then the answer changes, right? If both answers are given, how to deal?
if both answers are given as in,
So one answer is directly given, just with the question marks, and another answer is given by changing one of the universal quantifier into existential quantifier.
okay,
Then how to decide which option is exactly right, and assume that there is only one option correct.
then you have to follow the same scolemization technique. See if there is an existential variable, see if it falls within the scope of a universal quantifier, and proceed accordingly.
Okay, okay, sir.
Yeah.
Sir, can
Yeah.
you explain once more one example for well formed formulas with an example?
So a simple example that we just saw is like alpha and beta, where alpha and beta independently are formulas, are well formed formulas, assuming. Then alpha and beta will be a well formed formula. If we have alpha, if we have, let's say, alpha, beta, and something like this. This is well formed. This is not well formed. Okay. This is
Yeah,
just an
okay. Thank
example.
you, sir. Yeah, thank you, sir.
Okay. So I think
Sir,
we
sir,
are,
in the sir, in
yeah.
that material after the solemnization, after 2 more steps, we got one example. If there exists something called number that is even and odd, then that is flat. So this example, is there anything related to solemnization or anything?
Khalid, your voice was slightly weak, but I think you are saying
So that
some.
example,
Which example? This example.
after the column constant and that slide, we got one example stating that if there exists a number that is even and odd, then the earth is flat. So what is
Okay.
this about? Is it related to column or something else?
Um, Let me see. Yeah, you are basically scolemizing it and
Yes,
then
sir.
making inferences. That's what it is about. It's an example.
No, one next example is given. Number even odd number and just before this.
Yeah, this is the one, right? This number, even, or this one.
Yeah, this again. Yes, sir.
Yeah, so this is just
Is
an
it related to
example.
column?
You are given a sentence, you convert it into first order logic, then you see if this can be converted into scolem function, scolem form, and then you make inferences using the scolemized versions.
Okay, sir.
Okay.
Sir, up to this unit, these three is okay, we done it. And unit 4 suddenly it appears exponentially more material is there. Is it same? And the week number 5, again only one of practice assignment is given. So I hope so. Let's continue. What will be the situation, sir? Week number 6 onwards.
Your voice was again
Week 4
breaking, but
is
I think I got a gist of what you were saying is that till week 3 you had relatively simpler concepts. From week 4
simple.
onwards, the complexity of the topics
Yeah.
has suddenly increased. Um,
Yes,
so
sir.
this is expected, right? We will start with something easy. We'll go to something a bit more complicated. We'll deal with that for a couple of weeks. I think week 6 will have something to do with prologue. Week 7 and 8 will
Okay.
might have something more to do with that, or maybe not. Will maybe that will introduce some other concepts in knowledge representation, and the last few weeks of the course will be very simple again. That I can tell.
Okay.
Okay.
Sir, some we have AI this concept. Somewhere something will be there building block at Lego for future and all. So which portion is required till the end? Like this columnization is required till the end while formulating the forms and all.
So these are different topics that you are getting familiarized with throughout the different weeks of the course. These may be applied in different domains and different problems. It is not necessary that what you are learning in week 4 will necessarily be used in the topic you learn in week 11, let's say. Okay, but these can be related or independent topics that you apply to some problem in AI.
Relevant to our course, sir. Actually, first order logic itself is okay. Everything can be covered. So with that only we are going further, is it?
No, we will stop with first order logic after a few weeks and then move to something else also.
Okay, sir.
Yeah.
Done. Thank you, sir.
Okay.
Sir, one more question is see, if I want to get a previous year assignments, where can I get it, sir?
In the live sessions. So the
So in the
if
live session, you'll be showing just only
so these
maybe
questions,
2003.
so I don't remember the
Yes.
exact year, but the questions we are discussing are from the previous iterations of the course. These are not something that, okay, some of these I have come up with myself, but most of these are just from previous versions of the course. If you want,
Uh,
if you're talking about the exam, that I don't know. That I have tried to get access to in the past semesters, I haven't been able to. So if you know someone who has actually attempted this course before and has a copy of the question paper, you can use that to practice. But I don't think I have access to previous year's question papers.
no, sir, I'm not asking about the final exam question paper. So, none of us will remember that questions even.
Hmm.
I'm asking just so I think you were discussing about so whatever the discussions you what are the questions you have discussed today? It is from 2023, right? 2024 or 23?
I'm not sure of the year, but it must be something in the past 3 years.
Yes, sir.
Yeah,
What I'm asking is like year-wise assignments since the inception of the courses. Where do I get?
I'm not sure. You can ask
Okay.
this query in the discussion forum and see if anyone has access to any such resource.
Okay. Why? Because even after a lot of explanation, I can understand like you have put a lot of effort in preparation in explaining to us, but still like we are. I'm not talking about others. I'm not sure that I'm going to get 100 out of 100 in this assignment.
That's
Because
okay.
still while you are explaining simultaneously I'm going through the current week assignment, but still sir like there is a lot of ambiguity.
I
I don't know
understand.
like
That's
I'm
fine.
really scared, sir. Like how the final exam I'm going to pass or not. Like
See,
you believe me? Like I have registered even for other courses. Like I'm putting lot and lot of effort is only on this course. Like rest of the courses, like if I can go through that PPT or lecture materials, that is fine. Like I'm sure that I'm able to answer assignments and pass the exam. But this exam, I don't know like what is going to happen.
like I said, see, there are two ways in approaching a course. One is purely from the point of learning something, one is purely from the point of getting grades or passing or not passing, right? So there has to be a balance, and that balance has to be decided by your individual priorities. Okay, for different people that will be different. For someone might have enrolled in this course only for the grades. Someone might have enrolled in this course only for the knowledge, or someone might want a balance between the two. That depends on individual to individual, and there is no correct approach to that. Every approach is fine. Every person has their own expectations from a course, and it's completely fine to follow that. um, what I would say is that cater the way you approach this course based on your expectations from the course. Like if you are expecting to gain, if you're more inclined towards using this course to gain information, then don't worry about passing or failing. There will be no student can get 100 on 100 all in the one go. I also haven't got that. That is almost a rare event. Okay. um, if you are focusing, or if you're more inclined towards the grading part of that course, yes, you can spend more time trying to sort of doing more practice and brush up on the aspects of the course that will help you gain uh, close to full marks. So you have to tailor your approach to the course based on your expectations from the course, is what I wanted to convey. But the bottom line is, do not worry about the grade from the beginning. Worry about learning the concepts initially, and once you have some level of understanding of the concepts, then we can worry about how to improve upon our understanding of those concepts to increase our grades in the final examination or the assignments. Okay.
Oh. Definitely, sir. That is a thing that I agree with you. But in NPTEL certification, we have a clause for this assignment marks also, right? Minimum, like we have to score this many marks. Even if you are able to get good marks in final exam, and if you fail to get minimum marks in the assignment, then we will not be certified. That is the thing. I agree with you. Like. In due course of time when the concepts go on, the previous concept would be easy, but assignment will not come back to us, right? That is the main issue, sir.
So the only way I think that can be addressed is practice, practice, and practice. That's the only answer I have.
And one more thing is like so if you take domain certification in AI, we don't have another option for this course. So rest of the courses alternate options were given. Only for this course there is no option. So
I
that's what we that's what I'm much very worried. Like I'm
Yes,
planning to.
sir. Of course, for data science also, this is one of the mandatory course.
Okay. So that is something that I'm not
Ma'am,
really.
actually in data science, at least this is listed in electives. We can take other elective, but AI domain it is in the main course. Like I
Ah,
mean,
okay, okay, okay. Yes, sir.
I
so
I
in Roman number two, I think there are no options for this. That is the main problem.
I
Yes,
can
sir. Yes, sir.
understand, and I honestly I don't have much knowledge on these kind of aspects of the different courses. I yeah I so I can't really comment much on that. But yeah, all I can say is just try your best, and that is what matters. Effort matters, and yeah, that's all I can say. Um,
Yes, sir. That effort also should be very high because you know that domain certification criteria is different. At least 55 marks out of 100 we should get. In the sense, like if we just get some 10 marks in assignment and 30 marks out of 75 in the final exam, we will be getting only 40 marks. We will not be, I mean, that cannot be used for domain certification.
I see.
So like there are a lot of clauses, and apart from the clause, there is a lot of difficulty in making these courses. That's what I'm very worried. And as I told you, there is a compulsion to take this course as a core course in AI domain. So mixing all this together, then you can understand. And moreover, like I can, you may be a researcher in this area, but we are very new to this, and like we are very navy to this course, and you can understand. I think what is our situation, especially what is my situation.
I can understand that, but yeah, like I said,
Yes.
practice is the only way forward, is what I can say. If majority of you feel that the way these domain certificates and so on are designed need to be changed or upgraded, then you should convey that to the NPTEL team. If I am sure that
Yes, sir.
if a majority of you do
Actually,
convey that, then
recently when I went for a star event, we personally told people at IIT Madras like there is a difficulty. Sir, not only this course, sir. You can take any course of Deepak Kimani, sir. It may be problem search methods. It may be constraint satisfaction. It may be this thing. All these courses, I don't know like why it is designed in such a way that it's very difficult to understand.
see,
But apart from
that's what
that,
I'm
as of my knowledge, I already hold a certificate in I mean domain certification in data science. I have never found such an ambiguity and difficult course.
that's I mean, like, I would again repeat what I said, that some topics, some areas are inherently a bit vague and ambiguous, and hence difficult to understand in the initial few attempts, but it gets better with time. And yeah, also I think we are running really out of time. I'm sorry for
Yes.
interrupting you,
Okay.
but I'll have to end the meeting.
It's okay.
But yeah, we can
Let
continue
us
again
discuss.
in the next live session.
Yes, sir. Thank
Yeah,
you.
thanks all for attending, and let's reconvene next. Whenever we have the next live session, I'll again repeat that probably next Tuesday I won't be available, so mostly like the live session will be rescheduled. But you will be notified of the rescheduling on the Swayam portal, so keep following that. Okay.
Definitely, sir. Thank you.
Okay. So see you all next week.
Thank you, sir.